Wrong keyboard. La 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 la. Let's say that. Do all. Why not? See if this is working. It came up, didn't give me a timestamp. How do I set a timestamp? Don't know. Doesn't let me take in. Alright, let's try that. That works. All this rubbish here. Fine. Got silly things in there as well. That's always good news, isn't it? Hey, isn't it? Just do that. Muppet, what are you up to? That gives me a bigger screen. Good. I've got a bigger screen now. Yay. And I can chat. Welcome to Amberskies. My name's Blades. On this particularly day. Visual Studio. Okay. That's good, I guess. This is what we're looking at. The code is on GitHub. For the start code is on GitHub for today. So if you want to download it, you can do so and follow along. But I wanted to talk about this. I don't normally. I noticed something in the offline checks that I do, which you don't normally get to see. Today you do, because it's interesting. And it's interesting because it proves a point that I've been trying to say for ages without any kind of visual proof. And it comes with line 10 of our box rbg.obj file, which is a vertex or a vertex position. It's been recorded. Actually, we can show 9 and 10, I suppose, but it's been recorded as minus 9.999 and positive 0.99999, and that's come out of Blender. That's what Blender's done. It says it at the top, OBJ file, box rgb.blend. So it's come from Blender, this 2.979. Okay, so I know where it's come from. I know who to contact, but it's come up with this, and we know that that's wrong because I set it to 1. Everything should be a 1. It should go from -1 to +1, which is actually 2. It goes to 0 and then to the positive. So it's 2 meter by 2 meter square box. Bear that in mind. If we try and put it on a 2 meter by 2 meter display, that could be interesting. So what I'm going to do is I will put a breakpoint in there at the beginning of where we do the ending part of just chucking out all the numbers, because we know that they're correct. We can count them, and well, I'll show you in a second anyway. So debug mode, let's run it. Are we on? Actually, is this video working? Twitch wasn't even working yesterday. I couldn't even get a stream to run on Twitch. Have I got something running here? Yes, I have. Oh, wow. So here we are. We've got the break in. Pop that to the... Let's pop that to the back. There we go. So we've got our breakpoint in, and being nice, Qt Creator has told us what variables we're using. So let's just have a look and see what variables we need. So I've moved MTL down here so as not to confuse ourselves. Here we go, here's the variables, and the first variable we've used is material. Material something. Material file name. And that should be boxrgb.mtl, which is the MTL file. MTL lib boxrgb MTL file. So it's picked up that. So material file name, material lib file name. We've got that. That's the first thing that we've got. Next on the line, look at vertex data. So vertex data, here it is. And we have 8 items, 0 to 7. 1, 2, 3, 4, 5, 6, 7, 8. 8 items, 0 to 7. Let's go 7, 6, 5. Let's have a look at 5. Oh, what the heck is that? So it should be 0.9999999, and we've got 0.99999989867. Oh god, something weird. 1, which we get, and then we get 1.00001, and we get 1.95367. What's going on? The truth is, floating point numbers are inaccurate, and the storage of them in a modern machine is very inaccurate. When you go past, what, 4 decimal places? You can get accuracy to 4 decimal places with some kind of certainty. Even then, you would have to probably do correction on it. Is this worth correcting? No, it's not. The accuracy is within boundaries that we can cope with, I guess. It's not going to be visible to the human eye, put it that way, that our box is a little bit smaller on one side, or whatever, or on a couple of sides, or one of our vertexes is out by a smidgen. In fact, it'll probably help our program get the vertex in the correct position, because it'll be a pixel on a screen. It all depends on what size the screen is, too, what kinds of errors we're going to get, because those measure pixel positions rather than actual numbers. That's interesting. So we've got this floating point error that we know of. That's interesting. Which way around are these triangles made? Don't know. I'm hoping they're counterclockwise, because if they're counterclockwise, we'll be alright. If they're not, we could have a little bit of a problem with that as well. Yeah. So that's your first thing to be aware of. Have a look at 2, for instance. There you go, -1, -1, 1. Is there? -1, -1, 1. Notice 0, 1, 2. It's not that one there. It's not 1, -1, 1. That's the one before it. 1, -1, 1. So we can see that all our data is coming in correctly into the vertex data, but it starts at 0, not 1. Bear that in mind. Bear that in mind. Why? Let's have a look at the vertex normals, make sure they're coming in correctly. We should have 6 items. 1, 2, 3, 4, 5, 6. Let's have a look at 5, 4. Let's have a look at 3 that's got minus zeros in. And it has minus zeros in. You can have a -0 float. Yeah. Should that be corrected? Yes, it should. Are we going to correct it? No, we're not. The -0 comes out in Boolean logic as a 0 anyway. We'll see how that affects us later on down the line when we do calculations. If our calculations seem a bit odd on the results, like there seems to be a minus being added in there somewhere, we know where it's coming from already. So bear that in mind. Vertex normal's done. What else do we pick up here? Use material. There you go, use material. We have red, green, and blue. Red, green, and blue, but they're inserted in between here and here and here. But we've recorded those in our face value because I've been sensible. Let's have a look at our faces. Face element, here we go. And face element, we have 12 items, which is 3 times 4. Just have a look at 3, number 3. Okay. Current color is 0, which if we have a look in here, it's red. Have a look at use material, 0. It's red, so that ties up. That's good. In the next one, it's current color 1. Use green. That ties up. But what about all the rest of this stuff here? Let's have a look at number 3. So our normal indexes, we've got 1, 1, 1. We should have 2, 2, 2. No, we shouldn't. We should have 1, 1, 1. Because we started at 0 and this starts at 1. So it should be 1 less. We've got a 0. So if we have a look at 1, 1, 1, we will get that one there, 1 minus 1, 1. Is the second bottom vertex. So that 2, 2, 2 refers to line 6. Great. So we have a conversion problem already that we are at -1 on the normals. Definitely bear that in mind. And then on the third normal, we've got minus bleh. And that one is for quads. Is it? Are we recording that? Should we be recording that? No. That information exists. That's dangerous. That needs changing. That should be a 0. We've just got a spuriously random number in there. Yeah. I don't like that. Texture index. We don't have any. -1, -1, -1. Oh god, what are we going to do about that? It's a spuriously random number again. Vertex index. We've got 765 again. 8, 7. That's 7, 6, 5. 1 less. Because we start at 0. And we've got that spuriously random number in. So that's the first thing we've got to modify, I think, today. Our spuriously random numbers. And if we look at the next face, it comes out with the same kind of numbers. 2, 2, 2, 3, 3, 3. Correct. -1, -1, -1. Correct. Nothing, nothing, nothing. And 4, 1, 0. And I've got 4, 1, 0. 5, 2, 1. Yeah, that's correct. Lovely. Our data is correct. And we still have spuriously random numbers in there. So I'll just continue our program to the end. Drop you. Can close you, close you, and we can come back up to full. So where we're actually doing our face, we are recording this data here. Pushback, new model, face element, 1, 2, 3, 1, 2, 3, 1, 2, 3. There is no 4. So we're going to have to look in our structure. It could be our structure's wrong. Face element, which is more likely. And yeah, it is. We are looking at too many numbers. And that's because of the quads. So we're going to have to put an extra line in, which is int. And what we're going to put in here, 0, I suppose. Don't even need to put an int, do we? Put 0, comma 0, comma 0. Make them all zeros. Could cause problems. How's about no, I can't even do that. Forget it. I'm just gonna mess up. Forget it. No. We have to ignore that value. I can get rid of it just by putting 333 in there. And as you can see, we do actually have that there. That might stop it from happening. Let's see if that does. What I'm doing is I'm setting the memory to 0. I'm hoping. I just don't want junk memory flying around. Let's see if that will recompile to give us something useful. On that 4th slot on the faces. It might do, it might not. Let's have a look. Face element. Yeah, it's putting 0 in now. 1110. So we're not getting a junk element at the end. That's what I wanted. That's lovely. Lovely. Just wondering, should we put it to -1? Doesn't matter. We're not going to be checking it. It's just that I don't want a junk value lying around. Ah dear. I also forgot about it. Even worse. Okay, carry on to the end. And all we're going to do is close that. Okay. And then we can close it. Everything's gone. That's done. We've looked at everything. We know what kind of data we are now getting. And that is very, very, very important. I've got a window covering some. Alrighty. Lovely. Everything's looking good. Is everything looking good? I think everything's looking good. So we know what to expect. If we don't know what to expect, we can put a breakpoint there and run it as debug, start debugging, and we can read what the values are of everything. We don't need to print them out to the screen. We know all the values of these, so we don't really need to print all of these out to the screen either. But I'm going to, because I like the information. There you go. Right, what we're going to do next, we'll have to open these up, Control / opens those up, and we'll open these up as well, Control /, and we need to do that as well. File close does help. So we forgot to close our file, so I thought we better put that in there, just in case it's needed. You know, the kind of thing that is useful. Let's get rid of all of these extra M's. They're useless to us at this point. M's, yeah, you can get lost as well. New material data at 1. MaterialName. Unknown type MaterialName. Have I spelt it wrong? No. Okay, what's this first one? Unknown type, diffuse texture map. Alright. It's model. We're missing model, aren't we? Missing that. So that's what's happening here. Okay. Lovely. Let's pop it in then. Alright, so if it starts with map KD, and we've got all of this lot again, haven't we? So let's have a look at this. I was looking at something else there. Console, resources. Let's have a look at our OBJ and that one there. We pull you back across. Yep, we can. So we're looking for map KD. Map KD isn't there. And that's because it's colour. That's a texture. That's the texture map. NE is a material name. So NE blue, green, red. So we're recording it again. KD is your diffuse colour, which is the bit that we're after. That's our R, so blue in this case. RGB, it's in the reverse order. Oh wow, I never realised. So red, KD 64, and a little bit of B, never mind. Green, 64 in the middle, a little bit of red. And blue, 64 at the end, with a little bit of red. Okay. So those should work. Those should work for RGB, but they're in reverse. Oh. That's not going to match up with our first lot of data, is it? Detransparency, 1, 1, 1. In other words, There's no alpha value. That's your alpha value, D. Illumination 2, you can read it if you want, but I don't think it gives us anything. It just says reflects light, if I remember. Reflects light 100%. Yeah. Nothing, not glass or anything. I don't know. Hard to work out. We'd have to look at that. So what's that's looking okay then. That's what we're reading in. So let's get rid of you, and go back to full screen. Alright, we don't have data at 1. Of course we don't have data at 1. Alright, let's just take you with a Alt Shift and hope he doesn't do something strange. Delete that lot there. So we can see more of the line. Right, where are we up to? So, MTL file. What do we need to do? So we need, we need this slot again, don't we? So copy. Paste. So file in. Really? Okay. So file in. View file does not provide a call operator. Got you. Q file, and this will be MTL underscore file, but file path now equals something slightly different. We're going to have to find our file path this time. I'm going to make it automatic. So file path last time was that. I'll just copy our file path. We know that that was correct the first time. Well, it isn't, obviously, this time. So file path doesn't equal that anymore. It equals that bit, but not that bit. That bit's not right anymore. But it is a plus. And we have stored it there. So we can copy up to that. Don't need to string, do we? No. So that should now give us our MTL path. Let's check it. Let's check. We're getting the correct material file name. At the end, we'll need a close as well, won't we? Okay. So what notes have I got on this one? Okay. load the corresponding MTL file. Material library. That's what it stands for. Alrighty. So close the file in. That's good. That's done. Better change that to MTL file in. Don't need that. Yes, we do. Q. Happy about this bit, text string. Okay, text string. MTL in. We have to get a different buffer because that's been destroyed at this point by that close. Okay, we're getting somewhere. I want to check the file path there, didn't I? Alright, let's just get rid of those lines again, because we can't do them yet. Control. Okay, let's just check the U lines out as well. Control, I don't want to be opening files. Doesn't matter. Put it here. Close. And who are we closing? MTL file in. There we go. That'll do. As long as we close it, tidy up after ourselves, everything will be fine. I just want to make sure we have another one of these. That there is correct. File path. Dot to standard string. Okay. And that is an std colon end line. Right, okay. That'll give it an extra line in front, so it'll be separated up. Okay, let's just run that. See if this output here agrees. That's our file open, or the start of our file open, and there's our file close. Yeah, I'm happy with that. Didn't cause any bugs. Still got this view open. There we go. Resources obj box rgb.mtl. That's the file name or file path, I say, that we've got. Does that agree? resources, OBJ box RGB.mtl. Agrees. Why can't I get rid of this? Thank you. Strange. Right, so we need to get to the point where we've got the data. So we've now opened it, we've checked to see if it's open. We've got a stream of text coming in other words, a buffer. Now we get that lot. Okay, let's put that in the right place. So we're trying to repeat everything as was. Let's get rid of one extra space there. I'm going to keep that in actually, because that tells us material file path. There we go. Looking good now, I've got a coffee. Yay, we're doing well already. Wow, what's going on? Things are starting to work, and we can see that they're working, which is not a bad idea. We're just repeating what we did before. We're not repeating that. So we've got a do while loop. So let's put that in. Do. While. Well, line. Where is line? There it is. Copy that. Oh, wait a minute. We can copy it all the way up to there. It's all the same. Repeated code. That QString list doesn't need to be repeated. Data is already that. Oh, it does. Fair enough. That's okay. Here. And we'll tidy all of this up. Yes. Yep. We can now pull these out. Like that. They should now work. 220, go away. 4. That up. I'll rename that to vectors. There we go. So, that's looking good already. We've now built ourselves a file path, the opening of a file, an MTL in, which has to be read here. Okay. So reading the MTL in a read line trimmed, yeah, that's good. We get the data, which is line split. The data gets saved. And you're in the wrong place. Okay. Readability on that line is awful. I'll pop you in. What else have we got now? Got some readability to it anyway. That's good news. Anything else I need? Not really. We just need to check them. Okay. Alright, I don't know what that's actually going to equal. Right, so we've read all of that lot in. Okay, what we're going to do next? We'll have a look at what we've read in. STD. Cout. We'll do another set of these. I think. We've got 1, 2, 3, 4. So. Oh, for God's sake, why'd you do that? Right, what we're gonna set out here. Texture map. And that's going to be a file, isn't it? I think it is. I'm just going to call it texture. I think it ends up being a file. So texture map equals, if it does, and we haven't got one, what do we get? This is number of, isn't it? Yeah. That's going to be an interesting one to look at. And we're just going to take it out of there, aren't we? Diff texture map dot size. That's all I want to record at this point, to see if there's any data that I need to look at. I should have 2 semicolons now and at the end, and I don't. Oh, okay. Fair enough. Next one is going to be none of any's. Material names. And that's going to be material names name dot size. And I should have the next bit done for me. Ah, messed it up. Nope, messed it up still, every time. Got ya. Okay. Next. None of what we got next. Colors. This should agree with the num of colors that we had before. This is where I think I've got it wrong in the past. Definitely. What we got here? Diffuse color. Dot size. There we go. And last one and not least, num of alpha values. Color alpha values. If you don't know what color alpha values are, it's transparency. That's what it equates to, or what I'm going to be using it for, should I say. So, transparency. There we go. Blah, blah, blah. That's closed. Alright, and that's where we're up to next. Now, we also know that some of our data's wrong. First of all, let's run that and see if we get what we expect. It's a straightforward run. There we go. We expect no texture maps. That's correct. Material names. We expect 3. Number of materials. 3. Number of colours. 3. Number of colours. 2. Number of colour alphas. 3. You see, the materials are just colours and texture maps that you can place on top of your object to colour it or to add texture. Is why we want this. Okay, I know that that is because we go 0, 1, 2. What I don't know is why our colours is 3. I would have thought we would have gone 0, 1, 2. Interesting. So what I'm going to do is I don't want to hit that. Right, I know I'm getting 3 and 3 for those, aren't I? Yeah, okay, doesn't matter then. We'll pop it there. We'll debug. I'm interested to see what we got for them. I think it's telling us the truth. So, diffuse texture map. Zero items, so there's nothing there. Okay. Material name. 3 items. blue, green, red. That's correct. Diffuse colour. Got 3 items, but we have blue, green, red. Blue, green. Oh, of course, yeah. Those are the actual colours. Looking at the wrong one. Just bear with me a sec. What do I want to look at here? I wanted to look at materials, didn't I? Colours. It's use material. Red. Oh god, green. Blue. They're in reverse. We have to write a search function for these two. Use material and material name, or we can reverse all the data that's in here. Is that going to work? No, because this data also gives us the actual colours. Okay. So that's right. Damn it. Damn it, damn it, damn it. This is one of the these are the problems you have to face when doing this. So diffuse colour, we are agreed it's 3 items. So we have blue, green, red. And luckily I've named them as well. In the .header file, in object data.structure, I've actually headed them properly. So you can tell what they are. And transparency should be 1 for everybody. Should just be 1, 1, 1. I often ignore transparency and just put 1 in anyway. But we're not going to. Because I do want to be able to do transparent objects. I don't want to have to add it later. Right, so we've got a major problem already. And I mean a major problem. And the major problem is our materials have been picked up in reverse. That's just fantastic. So number of colours 3 is correct because the number of colours here is 012. I'm sure I used dot size on that one. No, I didn't. That is just literally a readout. But it's 3 materials. We're getting 3 material names, 3 colours, and 3 alphas. All matches up. That's good news. Right. Now starts the fun. Construct the model data. This is where it gets dodgy. Very, very dodgy. We have to convert everything to OpenGL. So, first, convert all data to OpenGL and no, I won't put and. I'm going to put NB. Materials from the MTL file are read in reverse order. No, that's wrong. Material names. Not the materials, not the colours. Colours are correct. Well, they're in the reverse order, in blocks, I suppose. But we can deal with that. That's okay. As long as we get the right material name. Any comments? Anybody? You know, any. Looks like we may need a search to assign the correct material. Only matters with colours. Doesn't matter with texture maps because usually you only have one texture map. But on materials, it's going to reverse them. And how will we know? We've done an RBG box, which is red on the front and back, green on the top and bottom, I think, and blue on the left and right. I think that's the order. I'd have to put it into Blender to find out. And we may have to put it into Blender to find out. I'm right with that. But it should be red front back. So if we come up with blue front back, we know we've got it wrong. We've got our colours reversed. Will not be good. Now, it's easy. All we're going to do is we're going to step through each face. And we are going to construct exactly what OpenGL needs. So first of all, we have to decide, what does OpenGL need? Let's construct what it needs first. OpenGL needs something called arrays. And we haven't got arrays, we've got vectors. So as we're sorting out all of these faces, we can convert them from vectors to arrays. Fantastic. This is going to be interesting. So, we've got a program already that will take those arrays and send them to the graphics card. We've already programmed it. So, let's have a look here. So, what does OpenGL require? It requires arrays, not vectors. Vectors will not do. It can't read a vector because a vector is stored differently to an array. Vectors can be stored all over memory, whereas arrays is just a chunk of memory. Because if you notice, all of these, all I've done is made a vector of addresses. And that's the address of where the piece of data is stored in. It could be anywhere in memory. Absolutely anywhere. What the operating system where the operating system places that memory, we have no idea. But that keeps track of it. And that's why I used vectors. Couldn't use arrays because we don't know the size of them. The size or how much data we're going to be reading. And in C and C++, arrays must be set up with a known size. Nearly a known size. But it has to be known at compile time. Or does it? What we can do is cheat. Because arrays must be known at compile time. Right. We have Amber 3D class. No, it isn't a class. It's a function that will load our arrays. Notice to the GFX card. And we have that. Been up on GitHub for ages. In fact, I don't think I've ever changed this file. Maybe slightly tweaked it because now I've got colors and no, I've got, at the moment I've got shaders, I've got colors and textures going through it. So we need to look at that file. Can I load it up from here? How much memory have I got on this machine? 16 meg. Alrighty, no, just go to this one. It's here. Let's just load that up. Sorry, I mean I've got two Visual Studios open. Perfectly fine. Visual Studio is only a memory hog if you actually start trying to compile these things. gfxloader.cpp. So let's see what it takes in. It's in Amber 3D API, so I know where it is. It's gfxloader.h, and it has a constructor, and it has a destructor, where it will destroy all the VBOs and everything like that. So we do need to call that. Well, that will get called anyway. That's okay. It destroys the buffers, textures, indexes, everything. So our vertex array objects, it'll destroy our vertex buffer objects. They get destroyed with that. Yeah, and it gets rid of the indices. Index buffers, VBOs, destroys all the VBOs. Right, so it does everything. It creates and destroys all the objects required for OpenGL. So we can make one of those. And we can make one using that template there. Current shader, null. We have to set the shader. And it takes two shaders to set the shader. And yet, I have only given room for one. Current shader. Okay. And yet I've got M color shader and M texture shader here. And we delete the shaders. Oh, we don't delete them here because we're passing them in. Oh, that's fine then. Doesn't matter. So, how this works is we set the shaders. So to do this, we set the shaders. No, we don't. We create an object from Amberskies API, and I think it's called GFX Loader. We set the two shaders, color and texture. Okay, because we don't know whether we've got a color or a textured object coming in. And then we send our arrays to the loader. Alrighty. So where are we actually up to? We are up to construct the model data here. And now we've got a note that we can use GFX Loader. That's good news. Load GFX Loader, load to VAO. So it's going to be GFX Loader, colon, load to VAO, vertex array object. I think it's in capitals. Yeah, I used to do it in capitals. And what I'm going to do is I'm just going to take a copy of its signature, this bit. Okay. We could pass that in. If number of text quotes is greater than or equal to 2. 6. Well, it's 6, but I put 2. We know it's 0. Do we know it's 0? Num text coords. What will your value be? That is critical. Let's just build and run that. 0. So number of text quotes is going to equal 0. We're going to pass a value of 0 in, which means it will not be a texture. It will be a color object. Fantastic. So it's going to pick up on that. So it's not going to run that bit. Else, color shader is picked, and we store the colors. Indices, data. Yeah. And we're storing them in the wrong order. Does that matter? No idea. We're going to find out though, aren't we? Now we already have shaders available to us. which we can create. So we are going to need to create shaders. Create shaders. We'll pop in there. Right, that's a job for that bit. Alrighty, just so I remember to do it. So we're going to need a for next loop. No, we're not. We are going to need to know. Oh, I did copy that thing, didn't I? That signature. Slash. Right, so what do we need? So we need, let's have a look. Let's use that signature and start deciding what we need. We need a uint. No, just a normal one, although, thanks. Indices. Indices. I always get that wrong. Is, oh no, no, square brackets for an array. And we need to know the number of indices. Okay. Well, we don't know that at the beginning of the program, so we can't put anything in there. Definition of a variable with array type needs an explicit size or an initializer. So equals 0. There you go. Unused variable. Thank you. Next one is a float. We're going to call it positions, may as well. That's what I've called it there. 0 in that one. Next one is a float. Call it colors. That's going to be fun. We might leave that to last. Equals 0. Might do that separately. Done that completely the wrong way around. Alright, so I've got 3 variables now. Positions, colors, indices, positions, colors. And text coords. So we only need 4 to get this thing up, running, and do freeing. Text coords. And that equals... Right. We're allowed to do that. Next. Next. We have a problem. The size of indices... Yeah, I'm going to get warnings, thank you. We don't know. Well, it's going to be the number of faces times 3. In this case, 36. So we are going to need number of faces times 3. Okay. I might just keep that open, actually. So, indices. Do this one first. Indices dot re. Okay. Dot. I'm getting nothing. Resize. Nothing. Nothing. How do we do it? Let's have a look. So in the converter, how did we do it? We took the model and we GFX loaded it, yeah. That's our model importer. That's the files. That's how to store a face. Yes, this is how we do it here. Ah, I used the vector. I cheated, didn't I? Damn. That's another way of writing an array. Damn it. And we're going to have to use the same way, aren't we? We can't resize these. Are you sure we can't resize these? Dibby-dibby-dum-dum. Search C++. How to resize an array. I prefer an array if I can get one. Why don't you want to use standard vector? Yeah, I know. That won't do it. No. Can't do it. There's no resize. Yeah, you can use realloc from C. Yeah, you can. But that's dangerous. So no, we can't do it. Fair enough. Stack Overflow for you. And we're going to use vectors then. So that becomes Q vector uint indices. As simple as that. Q vector float positions, as this is the easiest way to do it. Q vector, I don't believe this. Float colors and Q vector, and that's float. Now there's a problem here in that we haven't got the texture, or we haven't used the texture. So we are going to have to do that as well. So that is that line there, cut. And V. Okay, remove temp data and clean memory. Given as raw model. Okay. And here I have put it in already. Add texture if needed. And then we'll return the app. Yeah, that's good. Lovely. Lovely, lovely, jabbly. So we've now got our variables. Is straightforward. Notice that they are not starred, which means that QVector underneath it will store these as a block of memory on a page. Gets a page of memory. It's very wasteful. This is a very wasteful use of memory, which is why I don't normally do it this way. I usually put a star there, so you can put it anywhere. That line isn't needed anymore. That's good. It's just a for loop. Vertices per face, yeah. So we're going to need a for next loop that counts in threes, basically. And I've got a counter plus plus. But everything happens in threes. You can see here. So yeah, vertices per face. We'll take you. We'll take you. I also agree there. Unsigned int, just in case a different operating system treats it differently. So I will now be using whatever I put here, aren't I? Yeah. I'll just take it from here. Actually, I'm going to take those 3 lines there, because those are important. I'm going to look at all of this stuff in the middle, because that's the confusing stuff for a lot of people. Okay. Just like to please reformat that for me. Edit, advanced, auto indent. Last. Face element doesn't exist. Face element does. Right. So what we're using here is face element. Now face element we mapped up here. So face element dot size. We know how many face elements there are. There are 12. We know that because we've run the program and we've looked at it. So imagine that's 12. So it's going to go through this loop 12 times. So our box equals 12. So it's going to do that 12 times, but for each face there are 3 vertices. So here we have to go through each of the vertices. But when you have a look at face element itself, it has a ton of information stored in it. So let's go and have a look at a face element. Here it is. This is what a face element looks like. Let's just borrow that. That's what face element actually looks like. That's what we've stored in it. So that's what we know from that variable. Or that structure, should I say. And I'll just pop that in here for an indication of what it is that we're looking at. Control. There we go. So this is what we're looking at. This bit here, this face element. And I need a cup of coffee before I even look at this. Because talking through this is going to be a real biggie. I don't know how many of you are up for this today, because I'm feeling good that I can get through it in one piece. I've got nothing else to do today. Well, I could tidy the house up, but that would literally kill me. So I'm not going to do that. I'm going to do this, and I'm going to explain. I'm going to try and explain. No, I am going to explain it. Because we have problems, which I didn't broach in the last run through the original video. So this is an actual update. This is an actual update to the original video. Wow. I'm updating an old video from last year. Yes, folks, you heard it here first. But I'm not going to update it until I've had a break. So let's get that sorted for our break. It's pretty obvious just looking at that how we're going to do it. Because look, 1, 2, 3. There's 3 of them. Vertices per face. 1, 2, 3. So this internal for next loop, we can pull out all of this information. Isn't that awesome? That does start at 0, and that does start at 0, because remember, we stored all our stuff starting at 0, not starting at 1. So even though that says that, it should say 0, 1, 2, I suppose. But I haven't. I put it in 1, 2, 3. I wonder why I did that. It was to try and get rid of that 0 error that I've actually corrected now. So something that I knew was a problem, I've tried to correct and failed already. Wow. Oh, let's give you some music. I've got some new music for you. Yes. I had a comment on the last video, and it's reasonable, so we'll give you that music. Guy said, would you play my music? And as far as I'm concerned, I'm going to go and get a cup of coffee and play his music. Or Zymer Tracks. Here he is. Show his page. Zymer Tracks. Shout out to you, mate. You've got some music here. Just play it and I'll go for a brew. Feels like it. Let's have a listen to his music.
My phone lights up, but it's never you. I can't help but feel so lonely. I know there's things that I can't undo. I'm falling apart so slowly. Come alive when we're faded. The summer nights that we're chasing. Want this feeling to last forever, forever. I know it's hard for you to stay, but I can make it another day without you, without stay, but I can make it another day without you, without you.
Introduction to Fractional Shares. How to invest from just £1. This video is going to explain about fractional shares and show you how this feature enables you to invest small amounts with Trading 212 in even the largest priced shares. Let's go straight to the Trading 212 app. On the home screen, we can see different lists of stocks. Tap on Fractional Shares. Here you'll find a list of well-known stocks, many of which cost hundreds of dollars. For example, we have Amazon and Alphabet near the top, both of which cost well in excess of $1,000. The trouble with such large prices is that buying even just a single share requires you to invest a substantial amount of money in one company. If we buy one lone share of Amazon, for example, it will cost us more than £1,300. That's a fair chunk of change. Wouldn't it be nice then if you could buy just a portion of a share instead? Well, that's what fractional shares is all about. With any of the shares listed in the fractional shares tab, you can buy less than one share. You can even go as small as 0.001 of a share, provided you invest at least 10p. Let's give it a go by tapping on Tesla. We can see the share price is $404.05. And if we click on buy, we can now enter our number of shares. With a typical stockbroker, the minimum investment size
I can't run that, it's too long. Right, I gave a shout out to him, that's good. I mean, he put a comment on my video, I can't see why I shouldn't give a shout out to him. If he comes back with new music and stuff on his channel, and he has new uploads, then I will use his channel for music. But he'll have to come up with new music to do that, obviously. And I'll run his advert. Right, where are we up to? We're about to do this horrible for next loop. That could be important. Let's just check it. This is the faces again, isn't it? 012. Oh, yes, that's correct. Sorry. I know why. I know why. That's because our data was stored in 1, 2, and 3. It was data.1, data.2, data.3. So let's just have a look at that. Yeah. Zero would have been the letter F, which we didn't want. We split it, and the 0th was an F. We take the 1 off, and we put the correct index number in. Excellent. For it to start at 0. Yeah, that's fine then, as long as that index number is correct. So we're going to find that the first set is index. Is it? I've done it that way. Yeah. 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 We do have a variable has textures. Yes. As normals. Yes. Okay, so we have current color, has textures, has normals as well. That is fantastic information to have. So that is correct. So I can guarantee that is the first, the second, and the third vertex of a triangle. go. That's what that really means. It's just the notation doesn't look right. Because the first or 0th was the letter F. If you have a look back. Oh no, we've only got that up, haven't we? If we have a look back in console, resources, OBJ, let's just have another look at that box. Just to make sure that I'm right. Yeah, first is an F, and then we split it by slashes. So we've got space and then slashes. So that's what all of that trickery was about, resplitting it and all the rest of it. So the first item is that one. So the first, second, third item. First, second, third item. So it's space, first, second, third. Space, first, second, third. And that's why it looks a bit weird. Second and third. So alter my notes so it reads right. Okay. Lovely. So let's have a look. Each vertex or vertices will have an index. So let's do the indices. I'm going to go through this 3 times for each indice, and it's going to count 0, 1, 2. So it's going to be that times 3, 0 times 3 vertices per face, plus the vertex number, or I vertex. And that should be your indices. Let's see if I'm right. Index array, pushback. So each time we come through here, we are going to need the index array. That's our very first thing. And our index array is called indices. There we go. So we're going to push back a static cast to an unsigned int of count, which is that variable there, 0, times vertices per face, 3 times through here, which is 0 to 11, plus I vertex. So we're adding that one on. So the very first one will come to a 0. The next one it comes through, plus I vertex, will be a 1, 2, and then it'll go back here and that'll come to a 1 times 3 plus 0 is 3. So that works. Can't remember if there's a vertex, an indice missing off the end. There shouldn't be. Now, what we need to do for the position is push back. So let's get our positions. This is interesting because we're going to push back something. And it's got to be, at the end of the day, a float. And it's held there, our first one. Index first. But it's in face element. Which face element is it in? It's in face element count. So we want to go to the first face element, or 0th face element in this point, in this time. I'm just going to put space there because I don't know how many brackets I'm going to need. So it's going to be model. No, what do we call our face element? Face element. Exactly what we called it, okay. Face element, there it is. We open a bracket and we put count in. There we go. Now we want to get out the first vertex. We can put an arrow. So it's that one there, M vertex index, and we want the first one, which will be the 0th one, which will be I vertex. And if I then, hopefully it's a star. No, it's not. Dot. No, we haven't got it. So what does that give us? That gives us an int. God, I can't remember how I did this now. Ah, yes, vertex data. I've missed out that bit. Okay, I told you that I didn't. Right, so that gives us an int. So that can go in square brackets. That gives us the position, or the number, in which we can find our position. And our position is held in number of vertices, so it's vertex data. So that int is the index of vertex data. There we go. And if we put an arrow or a dot on the end of here, let's see what happens. Dot. No. Okay, give us a space. Arrow. Nothing. Yes, it did. It gave us something. Arrow. Yeah. Dot. I'll take you. It is an arrow. MX. So that gives us the X position. Yes, the X position only, which is a float for that position. So we now need the X, Y, and Z to get the full position. So we have to do it 3 times. Okay, we can bring that back now. So semicolon. But it's not in the same place. Well, it is, it's the same thing exactly. So the next 3 things we're going to need Control V, Control V. 3 vertices per face. So this is 1 vertice. X. It has an X value, a Y value, and a Z value because it's 3 position in space. And we need that 3 times. And that will give us that 3 times. And it will count upwards for the I vertex number here. So it will give us 0, 1, and 2. But that's a problem, isn't it? Because it depends on which face. The face, yeah, only gives us first, second, and third. Fantastic. Done. Colours are wrong. We know that because we've already realised that. Our actual colour has to be read backwards. So we need our last colour first. How are we going to do that? I'll think about that in a minute. So colours we can't do. Text coords we can do. So if we haven't done normals. We're not using normals. We haven't done lighting. You're joking me. We haven't even done lighting yet? Oh, please tell me we have. We haven't, have we? No, we haven't. No, we're just shoving it through as a vec4. Okay, so there's no normals. Damn, and I wanted to talk about that so much. It's got 6 normals. Same as positions, aren't they? We'll take colours. We'll leave till last. I'll cut you out. What we'll do then is Q vector. Oops. Q vector. And again, it's a float. I'm just going to call this normals. We do have them, so we may as well include it in here. We haven't got the Dubry for them though. Never mind, never mind. Vertex normals. So what we're looking for is vertex normals instead of that. But if it's going to be face element count. Yeah. Yeah, face element count. Well, it's an arrow. Single arrow, please. As normals. Then we can take, get one line done. Normals, yeah. Normals dot pushback. And it's going to be vertex normals. Vertex normals, open brackets, exactly the same as it looks above, face element. Count. Close brackets. Now we need the normals. Normal index. That's the one we need. That's an I vertex. Close, close. And again, we should have the 3 MX, Y, and Z. So copy. (274B) 275V, and then all we do is put X, Y, and Z at the end. the for loops will take care of them all. And all we have to do is push them back in order, in the correct order. So the correct normals with the correct vertices. That's that done. If, what's the next one? Text chord. Positions, normals, text chords, yeah. So if base element count has textures, and that's why I needed that variable. You won't find this in the original, probably. This is a redo of the original. We're doing it properly this time, all the way through. So if we've got textures, we can do the text chords. Now text chords are a little bit easier actually. So it's text chords dot pushback. I mean, there's nothing fantastic going on in here. Where do we put our texture chord? Let's just find out. Texture data. That's where we put it. Texture data. Open bracket. And we just need the index, which is in face element count. That's not right. It doesn't look right to me anyway. I'm gonna check all of this over in a second or two. Texture index. And that is iVertex. If I've got this right, I'm absolutely amazed at myself. Having a cup of coffee. And that should just be a UNIV. Oh hell, we've got a UVW. Oh hell, we're recording W's? No, I'm not recording W's. Don't think I'm recording W's. But we better check. Not that one. It'll tell us here. Is greater than or equal to 2. Current shader equals texture shader. True. So store data to attribute list 1, 2 texture coordinates. So it's 2 texture coordinates. And here it's 1, 3 colors. We don't do the 4th. We're only doing 2. Better to check. So 2H can be copied. That's a C, is it? And then a V, yeah. That's a U and V only. I'm not doing the W. Even though it's available there, I'm not doing it. I know it's 1 because I'll set it to 1. I don't care. I want the U and V value. I'm still worried about the count business here and the iVertex value here. So let's again look back and see that it is count and iVertex. You see what I've done here? It's awful. It'll never get used. That just doesn't, that makes no sense whatsoever. That's wrong. That line 150 there should not be there. I didn't check to see what I needed. And this is all wrong because it's giving us the wrong red, green, blue and transparency. Great. Giving us the wrong colours. So what we have to do is to take all our colour information. What colour information do we need? Let's have a look. Colour, we need the red, green and blue. We're ignoring the transparency at the moment. We haven't got 4 there, we've got 3. We'll ignore the transparency here. So at this point here, so I'm ignoring the transparency. Okay, I've got a thingy there, so let's just use it. I need to know what we've got where, and it's diffuse colour that I'm looking at. Thank you. 3 items. I need to go backwards through those items and reverse them. Wait a minute. Oh yeah. Yeah, they're all in the wrong order. It's blue, green, red, not red, green, blue. This is completely in the wrong order. This is reversed. So we have to take all of this and reverse it. Great. So number of colours is our initial one. And then reverse. How are we going to do that? How are we going to do that? It's totally reversed. Even now red, green, blue is reversed. So I can reverse the whole lot. So it's going to be a for loop. It's going to be index. No. Unsigned int index equals is it num colors. Num colors is held separately. We just got color, current color. There it is. It's 2. It's an int. No, not an unsigned int. It's an int. Index equals, and it's going to be a num colors. Is it? No, current color. I have to make sure that that variable is available. Whilst index is greater than or equal to 0, index minus minus. Yeah, a reverse loop. Right, that will get us from the current colour, which is 2, that one, back to 0, which is that one. And we need to copy the data into a temporary colours, which is a vector. This is coming from MTL, isn't it? Diffuse colour, it's here. Oh no. Yes. Oh yes. We have model diffuse color. Diffuse color. We need that exact same thing there. But we need to call it something different. We need to call it temp color. We'll call it temp color. Oh no, reverse color. Reversed color. So our first, and we need a counter. The index will count down. That will give us access to the diffuse color. We need something to count up to give us access to reversed color, which will be an int. Int color counter equals 0. So the first reversed color. So, oh no, we don't. We can use a pushback. Dar. Pushback. Don't need that. Beauty of vectors. So reverse color. Where's it gone? I can't spell it, most likely. There we go. So let's spell it correctly. Reverse color dot pushback. And it's just going to be the address or whatever information is in the first piece of information will have to be that one. So it's going to be diffuse color at that location. Diffuse color to red. I want that value. I'm going to have to new it as well. Model colon whatever it is. Diffuse color. Yeah. Float red, green, blue. Yeah. Alright, we'll just pop you in. Open brackets, damn. Yeah, open brackets. So we now need the red, green, blue. The first one is going to be I'm going to put this on a separate line. Diffuse color open index, and that's going to be it's going to be the last one. Yeah. Dot. Comma. Diffuse. 3 F's. Diffuse. Color. Index. And that's going to be RG. Green. This is silly. Diffuse. It's got to be done. Color. Otherwise you get the wrong colors. Color. I spelled that right. Index. Well, we'll find out in a minute. And that's going to be RG M_blue. And I haven't got it right because I didn't put a comma there. Why can't I get to that space there? Okay. That's correct. Alright. So that will reverse down the colours. Oh no. RG. No, there's something wrong. Diffuse colour 0. Material name. Blue. Yeah, when it should be RGB. So it's red. I want the second one. And the red is held in red, I guess. I'm gonna have to run it, aren't I? Damn it. Okay. That should give us reverse colours, which should say RGB. Yep. Let's try it out. I want to stop. Not there. Anymore. I want to stop before you do that. Yeah. That will give me a reverse colours marker. Building. Under R. Reverse colours. Red is correct. RG, correct. Blue is correct. They are now in the right order. 1 and 2. Fantastic. We've done it. Reverse the colours. What happened to the window? Something didn't go right there. Where's the window gone? Alright, don't know what the heck's happened. I think we've finally spliced out the memory. Not quite sure. But anyway, I need to run that and make sure we're not goofing. Right, that's running. absolutely fine. Lovely. So I've now reversed the colour. So we can use reversed colours. So if it doesn't have normals, what we can do is we can put an else here. Like that. And now we can put in colours. Oh no, it's not normal. Star. Do that one. Do that one. It's at the end. Else. We can place in the correct colours. And we've called it colours. Andy. Colours. Dot push back. And we can now take the texture. No, it isn't. It's a static variable, isn't it? Current colour. It's not 3 variables. So I have to take it from the face. The current colour is the index. And it's coming out of reversed colours. Yeah. Reverse colour. It's going to be a face element. This is why I had to reverse it all, because we're going to get our index from here. Face element count. We have a face element we're on. And we can get our current colour is the int. That's it, that's the int. So it's just an arrow to red. There. So that's our line. Copy that. And we'll paste it in twice. Control V. Doesn't seem to want to work. All right. And that's going to be red, green, and blue. We've checked and are correct. We've reversed the colours. We're taking the red and green blue from them. We probably could have done this at the same time. Yeah, I think those two could be put together. One colour equals 0, that'll work. No colours equals -1, that won't work. I'll just skip the for loop. That will be false. That being false means those brackets are discarded. We then set up the variables, yeah. We're then using the face element to get everything out of here. Have we missed anything? 1, 2, 3, 4 items there. Yeah, and 5 items there with the index. 1, 2, 3, 4, 5 items here with the index. That should work perfectly. How did I do the colours last time then? Push back. Yeah. Choose the current colour. Exactly the same. Yep. Exactly the same. But it comes out as the same code. Well, let's have this cup of coffee I made. Wow. Alright, so now we can create an object from Amber 3D API GFX loader. Wow. At this point, we have everything that we need. According to theory. Have we? Okay, what do we got? We have indices. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yay! All the way up to 36. There are 36 indices for this, that is correct. Which means we should have 36 vertices. Positions. No, we don't. We have 36 times 3. Which is 108. 107 minus 1 is 108. Sorry, 108 minus 1 is 107, yeah. 108 positions. That means we should have the same as normals. Positions normals. Normals. 108 normals. Yes, we have 108 normals. Can't tell you if they're right or not. Text coordinates. We should have 2 times 36, but we don't have any texture coordinates, so there's 0 of them. That's good. And colours. Colours. 108. R. RGB. Yay! Then it changes. At 36, it should change there. 36 one should be G. Red, green, blue. Yes, it is. That's looking good. Fantastic. Anything else we can check? No, not really. We've got 108 items, and that's important. We now have to get the computer to agree to that. We also need to know what is required at the other end. So this is going to be close. 10. All right, we need some information now. I need to know the size of each one of these. That's the next thing I'm going to need. We've got the numbers. We need the numbers. We create an object. Okay, we have to do the shaders, but I'll just get the no. Set to shaders. We send out arrays to GFX loader. Okay, let's do it here. Let's just put those in here. So we are going to need as we'll call it the same thing, num in places equals, and that is an int. And I'm just going to put dot size now. Okay. Next we've got int num position. Equals positions. This is what we would think it is supposed to be. Size. Don't worry, I'll go back and do the shaders in a moment. They're actually the easy part. And next I want colours, so I'll ignore you for now. So, alright. Num colours. Equals colours dot size. I hope I left myself some notes. I usually do. And if I haven't, I'm in trouble. I don't know what the answer is straight off. And it's num text coords. Dot size. If you can't read what's on screen, by the way, I just realised I haven't enlarged this. If you can't read what's on screen, please let me know. I can, increase the size of the text. Alright, all I'm going to do for now is print them out. I'm not going to send them off to GFX Loader. Because I don't think these are the right numbers. So we're going to do one of those std, look on couts. And we're just going to do num indices. Remember that it's 108 that we're looking for. Is the magic number. And this is just going to be num. Std. Okay. Fine. Std out. And this one is going to be num. What's next? Positions. Yeah. And that's just going to be num positions. There we go. Next one. Obvious what I'm doing. I'm just getting a readout on the screen. I'm getting lots of readouts on the screen, and there's a reason for it. People hate this. They use the debug tool, but no, I want this for future reference, not just for now. This isn't being taken out. All of this information I want on the screen. There. So that I can see it. Colours. Next. This is important information which I want to keep and preserve. What's this one? Num colors. And that's std end line. Lovely. And the last one, see out. Num blah 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 text chords. Just fits. Isn't that lucky? Text chords. That's standard library end line. Lovely. Ah, right. It's a message. There it is. Just so I'll get rid of that. I've still got an error. Oh no, still got a breakpoint. Alright. Let's just run it. Doesn't take long to run. There we go. And look what we get. Number of indices 36, correct. Number of positions 108, correct. Colors 108, correct. Texture coordinates 0. That's good. That's good. And to close. All I'll do is I'll add a \n there, posterity, to give it a new line. And that's it. So, what should we be passing over for those numbers? That's the question. Store data to attribute list 3 num colors times size of a float. I've done it here. Those are the correct numbers then. You are joking. I didn't know whether I had to put that size of a float in, because the OpenGL doesn't want to know the number of items, it wants to know how big the buffer is, the amount of space it needs on the graphics card. It doesn't care what. So times size of a float, times size of a float, times size of a uint. Oh. Num indices should be a uint. I didn't know that. Oh no, it isn't. It's because they're a uint. Yeah, that's right. That's okay. Size of a float. It's done it for us. And that means that all of these will go through properly, with the correct size of data being transferred in. Allocate data set. It's looking at a data buffer, that data size number at the end that's very, very important. We've got the data, but it needs to know the buffer size, that data buffer size. And that's what that's all about, why I need to know that these will be converted inside. So I'm just going to put in, these are converted inside GFX. I'll do it properly. GFX loader to the correct for God's sake. to the correct buffer sizes for OpenGL. Right, as long as I've got that note there, it means I don't have to multiply these things out by what they are. In other words, dot size times the size of a whatever. This gives back size gives back inline int, unsigned int, size const. So it gives an int back. So we're okay with that. Make sure we're getting the right variables back. Yes, we are. Size gives an int. Alright, that's fine. That works. Not. Otherwise, we have to do a static cast to an int at that point. So I'm happy with all of that. Okay. We create an object from GFX loader. Alright, let's do that. Let's go back a step now. I'll put it here. Hash include Amber 3D. I've already joined the library up because I knew I'd have to do this. API loaders GFX loader.h. There we go. I absolutely knew we were going to have to create this object at some point to load all of this up. I already knew that before I started, so I was prepared for it. Right, let's go back. Here we go. Let's do that line. How do we do this line? It's Amber 3D colon API colon GFX loader. I'm just going to call it loader. No, I'm not. I'm going to call it star loader. Go wherever it likes. Don't care where it goes in memory. Equals a new Amber 3D API loader. Alright. We've got that bit. We've got a loader now. GFX loader. And we now need to create the shaders. I've got to go somewhere to find the shaders. How did we create the shaders? Or did we not? Down to main. We're not bothered making shaders, is that why it all fell to pieces? Where's my shaders? Where's M color shader and M texture shader? Oh, we can do it with the API, texture shader and color shader. Well, that's hunky-dory. Really? Have I already done those? It looks like it. Hash include Amber 3D, API, shaders, color shader, hash include. I don't know why I'm doing it this way. Why don't we put spaces here? Amber 3D, API, shaders, texture shader. So that's going to be easy, isn't it? If we can remember how to do it, which I hopefully can. Last here. We're into the 300s already. Wow, this goes to 1,000 by the way. We're only in the 300s. Wow, that's awesome. Remember, I'm doing all of this in one file. This is the main.cpp file. I haven't gone outside of main.cpp except for Windows so far. And of course, we're creating these objects out of a library. Okay, create shaders. All right, we'll have color shader. It's going to be a star, and it's going to be Amber 3D, API, color shader. That's simple. Equals a new. I'm quite happy to put new all over this. Why am I happy to do that? Because it's in main. At the end of main, all of the resources that are taken up during main are released back to the operating system automatically. That's why I haven't put any deletes in yet. API. And I haven't bothered about deletes at all. Alright, color shader, done. Amber 3D. Colon API. And I'll have a texture shader, please, Bob. Texture. Remember, I don't know what we're reading at this point. That's the assumption. Our test object may be color only, but we have to account for everything. So we have to do this for both. This is why it's getting a bit better than the first time I did this. There we go. Right, so we've got loader, we've got color shader, we've got texture shader. We need to set them. So let's do that here. So loader, set shaders, should be pluraled. It wants the color shader and the texture shader. So color shader, comma, texture shader, which I spelled wrong. I'm an idiot. Texture shader. Right, so that sets them. Cannot initialize a parameter of Q OpenGL shader. You're right, you can't. That's get program ID. I remember that. And that's get program ID. I can do it that way because those are the shaders, the actual programs. Oh, Q OpenGL shader program. If that's the Q OpenGL shader program, should we not include Q OpenGL shader program? We're just passing a variable over. Does it matter? It's inside there. That's already got the include. We don't need it. we send our arrays to the GFX loader, load to VAO. We've got all the sizes, we've set that. What does it give us back? It gives us back a raw model, doesn't it? Remove temp data and clean memory. Okay. Should do, really. So, we have a loader. Load to VAO. It wants indices, int num indices. Okay, I think we can do this. This looks okay. So indices, comma, num indices, comma, positions, comma, num positions, comma. It wants the colors, comma, num colors. Get the idea. And text coords. Text coords, comma, num text coords. There we go. And then it's a semicolon at the end. No viable conversion for qvector unsigned int to uint. Star. Okay. What's that really telling us? What is that really telling us? Error. No viable conversion from qvector uint, also known as an unsigned int, to uint star, aka unsigned int star. And that's quite right. What it needs is the address of the first item of data, which is there. And it's the same with all of them. So you want to take the address in memory of where the very first position of data is located. Remember, it's stored as a block, because we cheated. So it then knows where all the data is. It knows the first position and the number of items of data. It can read it just as if it was an array. And it can pretend to itself, OpenGL can pretend to itself that it's just received arrays, which it hasn't. It's just received the first address of data. And that's how you get the first address of data out of a vector that looks like that. So it's and the name or the address of the position of the first item, which is 0th item of data. Very 0th item float. And it will pass that number. Because it's asking for an address at the other end, it gets that address. The address of the very first item of data, what we've given it. There we go. Remove temporary data and clean memory. Okay. I might be copying and pasting for this. Right, load to VAO, load to VAO. Gives a raw model back. God, this is getting long. Actually, no. Put this first. Hash include Amber 3D slash models raw model, and we will also have to include, because there are two possible models, Amber 3D. There are two possible models we can have. We can have a raw model with color or a textured model with a texture. We don't know which. Wow, look at all of this code now. Yippee. And I haven't even got to normals yet. Oh my god, we've got to add normals into this. Eesh. We should do it actually now, shouldn't we? I've done up to here with normal. So really, we should have int num normals, because it is going to come up very, very quickly, equals normal dot size. There's no reason to miss it out, just because we're not sending it anywhere. So it came after positions. I'm going to stick it at the end. std : cout. I haven't programmed it to normal state yet. Normals. And again, this should be 108. Num normals. std end line. Yeah, we're okay with that. Right, so we do have the number of normals, which we can just, it slots in here. Actually just slots on the end, doesn't it? No, I usually put it after the positions. It depends how you write your shaders. Right, so that's, I haven't written the shaders for lighting. Remove temp data and clean memory. Urgh. That's a mess. Right, so face back. Amber 3D : models : raw model, call it raw model, and it's a star equals that. Alright, so we've got our raw model. That's you. Find the GFX card as a raw model. What does a raw model have? It has the vertex array at object. It has the number of indices in it, and it also knows if it has a texture or not. Ah, it says that. It is a raw model. Right. We will only need the vertex attribute object and the number of indices. Also think about the texture. Well, we get the textures as well. If we go back to the return value, that's the wrong thing. If we go down to the return value, pushback, yeah, that's not the return value. The return value is here. Return raw model. Raw model actually has the VAO, number of indices, and a bool has textures. It also holds a bool as textures. And that's important because that leads on to the next sentence. Also think about if the model has textures or not. So we already have thought of that. I've preempted it. I've preempted it and already thought about it. So yeah, looking good. Unused variable raw model. So we're going to have an if statement. So somewhere in here, we need to load a texture. That's in our loader. Our loader can do that. Okay. And now we have the if statements. And this is where add texture. Yeah. I'm going to leave a gap there. Remove temporary data, by the way, is line 357. That's an auto. This, when in a main, will restore all memory used back to OS, the operating system, because it's the end of the program. At this point, it hasn't. When we're actually in executing the app and we've got the window up, we've got all of this data hanging around. It's a massive, massive amount of data that we could have just hanging around in memory, and that's why that line's there. As soon as we have completed here, we can delete, we can do our first cleanup. So at this point here, think about cleaning the original vectors up and releasing the memory. You only get a certain amount of memory in a computer, you know. It's not infinite. So once we've actually got a copy of what we want, we could release the original and keep our copy. Yeah. So that's your first cleanup, and our copy could be deleted here. At the moment, everything is. So what we're going to use our raw model for? Well, I want that on screen. Oh, have we got a full build at this point? I doubt it. We've got one unused variable, raw model, obviously. Let's just clean you. Let's have a look at this. Let's build. I'm building one file. Yep, raw model, that's the only thing. You would think if you'd written 360 lines of code, you would have made a mistake. Good. Index out of range. Thank you. Index out of range, blah, 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 line 463. Which index could there be out of range? The answer is easy. It's the texture index, which is out of range in this case. You have to have something in it. M has textures. What we can do is just do a simple check here, texture chord size. Or we can do a check before we finalize that. So if text chord, texture chords dot size is less than or equal to 0, then what we do is we take text chords, we push back, what can we push back? And that will stop it. Let's do a run and find out. Because now we will have one. See, we've now got one texture chord, but we don't get the error. It's because we are treating these as arrays, and an array cannot be the size of 0. It has to be 1 or more. Yeah. So the same thing goes for colours. You have to do the same check in case the colours is the same here. If colours.size, as it will be if it's only got a texture, dot size is less than or equal to 0, and colours dot pushback, and that's just looking for a float, and that's all we need, and that will stop future errors. What you can do is do that as an else. If text chord size else, if color size else, do that. I don't know. We might get objects with colors and sizes. Yeah, that's a bit awkward. I also haven't accounted for multiple textures either at this point, only a single texture. Yeah, great. There are things to think about for future expansion of this. But this now works perfectly okay, except for we haven't put it on the screen. Yeah, works perfectly okay. No problem at all. If this was a textured object, it would have one num colors and texture chords would be 72 there. There we go. if that was textured, not coloured. There we go. Interesting fact. Are we going to leave it here for the day? Have I confused everybody totally? What are we up to? 3 hours? It's a bit early. Things we have to think about next, anyway. Let's go through that. Well, what we'll do is what I'll do then is I'll put this up. This is the end of the video if you're not interested in things to think about. Ideas for improvement. So let's have a look. Current project. Commit. There's only one file we worked in. Oh, we did make an what alteration did we do here? No, I don't know. Okay. We now have a raw model containing all the info required to place an OpenGL object model on screen, and we need to prove that, and that's the beginning. That's going to be the first thing we do. If you can do it yourself if you want to try doing that first, so we'll commit that, and that says blah 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 blah. Committed to files. Good. Tools, git remote repository push. Blah de blah de blah, goes in the bottom right hand corner. Done, done, done. You now have the code. The code is public. Check. Make sure it is. It'll look better on GitHub than it does on my screen anyway. That's the wrong information. I'll go through amberskies.org.uk. Easy for me to do so. Amberskies QT. So github.com amberskies /amberskies_QT. That's your master branch. Let's look at Windows 10 branch. And we're looking at the console version of Model Converter. And we're looking at main. As you can see, all of the stuff that I've put in today is now quite happily sitting in here in main. All 300 lines. That's us. We're out of the woods. We're into the finals. The final stretch. Yeah. So that's where we're up to. The raw model. At 344. And the rest is just notes. Oh, I've got a load of notes in there now so you can follow some of my thinking about cleaning the vectors up and releasing memory. These arrays, don't clean these up yet. That would be here. Remove temp data. I call this temp data. Depends how you manage it all. Raw model here contains lines 354 and 355. Those two things there are contained in raw model. So you can do raw model and arrow and retrieve the VAO. You can retrieve the number of indices and you can retrieve whether it has textures or not, true or false. And we're going to prove that. So that's that. You've got the code. I don't like having that warning. What I'm just going to put is now we have. Oh, thank you. Thank you, Muppet. Now we have the raw model. Do we still need your model data? models array data? The answer is yes, we do, but I'm not going to go into why right now. What I'm going to do instead is, now I've got the raw model, is I'm going to do an std cout. What's the first thing? Is going to be VAO equals, and that's going to be raw model arrow at VAO. Oops. And I'm going to see what it says about that. STD. See, if you don't believe in, if you know what information you've got, it's absolutely a doddle. What else does it say we have here? Number of indices. So indices equals raw model get index count. STD, underline. And standard cout, last item is has textures. I'm just going to say textures. And that is a raw model. It'll come out as a number, unfortunately. STD underline. And if you really want to try this out, I'm not going to try and guess. True equals true. Because it's going to come up as a number. Okay, it's not going to say true or false. That's a bool. That there is going to come back as a bool. It says so under the tooltip. That is a bool. So let's see what happens there. Can we compile that? Without any red blobs? Yes, we can. What kind of information we're going to get out of that? What we get is indices is 36, textures is 0, true equals 1, so it's obviously false. And the VAO is an address. An address for the graphics card. I just put a \n in there. That's correct. That comes back as a OpenGL vertex array object. There you go, the object. Now it comes back as a number instead of the address that it's held at. Could be 1. As predicted, it's 1, because it's the only VAO we've made. Our vertex attribute or object, the thing that contains all of that points directly to all of this data that we have put on the graphics card. That points to all a small table which lists the address on the graphics card where the indices are, the positions are. No, it doesn't list where the indices. Yes, it does. Positions are, colors are, texture coordinates are, and normals are. There aren't any texture coordinates, so we didn't save that out, so that doesn't point in. So there's a 0 next to textures. There is no pointer to textures. It doesn't have one. Okay. There's 36 indices, that will draw a box. If we place VAO, if we say draw elements of VAO1 onto our screen, it will draw that box on the screen using those colours as long as I give it the correct shader. Theoretically. Will it? I hope not. I don't think I'm that good. So there you go, that's what the raw model holds. So you understand what the textures means. It's either a 0 or a 1. True is 1, so that will give 0. We'll add that. It shouldn't rebuild it yet. Yep, 0 if false, 1 if true. So we have enough information now stored on our graphics card to put our object on this blue screen. We have come to the last leg, and that comes up. Where are we, on Saturday? I think we're on Saturday. Are we on Saturday? Or what? We are on Saturday the 18th of April. Sunday's sailing, Monday's my day off, Tuesday the 21st we may finally get a box on screen. May get a box on screen if this main program, without all of those extras, just using a couple of things out of Amber 3D. So the only things I've written so far in Amber 3D, very lazily of me, I haven't done a lot in there. I'll have to do more. Is I've written the raw model, the textured model, the GFX loader, and the shaders, the shader pickups. All of these have to be upgraded. I'm debating, should I have a color model? No. Because what I can put here is handles colored models. And I can add their handles. Well, obviously textured models, because that's got details of the textures needed for putting a textured model on screen. So this will contain all in the information for a coloured model to be placed on screen. This will contain all the information for a textured model to be placed on screen. So we now have to split our pathway in two. We can't do both. We have to do one or the other. Yeah. So this sentence here gives you a clue. If raw model which has disappeared on me, okay. Raw model, there we go. There you go, draw the textured object. There's a problem there, obviously. Else. Draw the raw model as a coloured object. Is it texture or textured? Textured. Amber 3D models textured model. That should be correct. Easy way to find out. There it is. I got that one right. There we go. And that's the next stage. Put it on screen. Alright. 3:19. Coming towards 4 o'clock. No viewers, so stuff it. I'm going to stop here. I think I've done enough for one day. And yeah, that'll do it. Okay. Let's save that out. I'll continue that on Tuesday. Fantastic. I'd like to thank anybody who watches this video. I would also like to thank Zymatrax for his NCS, no do free. No special music that I'm allowed to use. Zymatrax for providing some music that I can use on YouTube for a break. I'm going to go and get another cup of coffee, sit back, relax. And, well, take care. Stay safe. And I'll catch you Tuesday. Bye for now. Oh, see you later. You close down. Bye.